Dear fellow coders, welcome to One Little Coder. This is day 7 of 8 days of Streamlit, where I teach you to build a Streamlit application every single day. And in the last 6 days, we have built a lot of different Streamlit applications. And today we're going to talk about Generative ART Creator in Python. So in the world of Web3, this is equivalent to your NFT. So if you want to create an NFT art, you can use this application and create an NFT art. Rather than giving one image, we're actually creating a Streamlit application where anybody can come and then do a little bit of configuration and create a generative art. Generative art, if you're not familiar with, is programmatically generated art where you use mathematical functions to create art. We're going to use a library, Python library called Samila. It doesn't have a lot of dependencies. Samila is a wonderful library where you can create generative art, and you can, as you can see on their GitHub repository, they have a lot of different examples. Most of the code that we have used in this application, Streamlit application, is directly from their GitHub examples. If you want to support this project, please go ahead and then give a star, and also like the developer has listed out a lot of different ways to support this project. I'm not affiliated with that, I'm just using it for educational purpose. So Samila is what we are going to use, and the way you install Samila is quite simple. You just do pip install Samila, and then you install Samila, and then you can start playing with generative art that looks like this. The API is quite simple. It has like a few steps, like 4 or 5 steps, and you can create art. I've already made a separate video on this library, and which I will link it in the YouTube description. Now coming back to the Streamlit application, you can see that in this process, in this particular day 7, we're going to learn a couple of new things in Streamlit that we have not learned before. For example, when you see this screen, you can very well think that we have never done a Streamlit sidebar before. So today one of the things that we are going to learn is how to do a Streamlit sidebar, how to add components to the Streamlit sidebar, and also we can see like we have different options. Now getting started with the code. The code is quite simple. As usual, my project folder has got 2 files. One is my app.py file, the second one is my requirements.txt file. The requirements.txt is again very simple and plain. As you can see, we have got Streamlit for web development, web app development, Samila for generative art, and the art that Samila generates is actually a matplotlib chart. So we need a matplotlib for that as well. So we need 3 libraries: Streamlit, Samila, and matplotlib, for us to build this application and deploy it somewhere we want. After we have this, now let me take you through the code one by one, so you can line by line, so you can understand what is happening here. And you can actually see like all these UI components that we have got. Like we have got a title, and then we have got a small text that takes somebody to the Samila's website, and also you have got the art itself, the actual art, or like if whatever you want to call it, like the art itself. And then finally, if somebody wants to reproduce this, we use a lot of math functions, random functions. So if somebody wants to reproduce this, they need a seed value. So we are also generating that seed value here, so that in the future you can make enhancements in this application where you can get the seed value from the user and then display the art. And when you talk about the sidebar, you have a couple of drop downs. The first drop down is first equation. The second drop down is second equation. It's supposed to be equation, we have to change it. And then we have the art projection. The projection makes the art look different. So now currently you see rectilinear, but again you can see that it's going to make a polar projection, so you would see more a circular projection. And also you can also see that we are showing a progress bar, and like I said, you just saw a circular a polar projection. And then I have a text called range, and then you can see that we have got colors. We've got the front art color, and we have got the back end color, which is the background color. So these are like the few options that you have. Like again, you can add a lot more options, and we are going to now start seeing the code one by one, so that you know what exactly is happening in each line of the code, so that you can make change, improve, extend, whatever you want to do. So let's get started. The first thing that we want is as you can see, the line number 1 that we have Streamlit application, which is what we are going to use for web development. Right now I'm using a pyplot Streamlit component to display the matplotlib chart, but there is a deprecation warning that you will get. So if you want to disable this deprecation warning, so you need to set this at the top, so that when the app is run, it doesn't show a weird deprecation warning to the user. And third, we are using matplotlib pyplot to actually show the chart. So like I said, Samila, the art chart Samila generates is a matplotlib. And then finally we have got the Samila components. So sorry for the typo. So we've got Samila components. Within Samila we have 3 important imports. One is generative image, The second one is projection. The third one is valid colors. We'll look at all of those components individually when we get into the particular section of code. As you can see, now, like I told you, a lot of math functions and random functions are used in this code, so which means we need random number generator, and also we need math function, which is to create the art itself. Like you can see from their documentation, everything that you see here is actually mathematical equations. So generative art is a huge subject, but there are certain mathematical functions that are given to us in the readme that are easy for us to use. So we are just simply importing sine and cosine function, and based on the user input, we are going to change the art based on sine or cosine. So that is one thing. The next thing in the UI is the title of the application. As usual, like we have generative art creator in Python. You can add some emoticons to make it look more emoticonish, emojis, rather than having plain text. So I'm going to add the Python emoticon. And then the next thing is you want to either add a subtitle, or you can mention a text where people can go read more about Samila on the web page. There are a lot of different ways to add it. So the reason why I'm adding below the title itself, because it requires a lot of math function and understanding, so that's why we are adding it just below the title, so anybody can click this and then go read about Samila and then come back to the app and then change the configuration, because whatever they're going to change is based on how the Python library is designed. So if they do not know any of those things, then it might lead to a little bit of confusion and ambiguity. So and we don't have a glossary section that will explain every individual thing. So we're saying that more details about the inner workings of Samila, click here. The next thing that we have got here is we have got the sidebar, and the sidebar, the way the sidebar is started is we are starting the sidebar with an equation drop down. So we call it first equation. EQ in this case is not emotional quotient. EQ is emotional, in this case it's equation, and it takes two input values. One is sine and cosine, and it is a text. Right now it's not a function, it is a text. So the output of these two select box or drop down is added to two objects named function1, function2. Based on whatever the user select, we are going to create value inside a function. So there are two functions we have. One is f1 and then the second one is f2. So based on the equation selection, you can see that if somebody has selected sine, then we are going to make the result using sine equation. If somebody had selected cosine, then we are going to make the result based on cosine. So that's what you would see, like the sine, if the sine value goes inside the function one, then the result is the first one. The cosine value goes inside the function one, then the result is second one. So this function is really important. So if you want to make enhancements in the generative art that are created here, if you want to make it unique, if you want to make it different, so this is like the core engine where you can make those changes within this function. This function actually goes inside like the generator below, generative image. So this is the place where you have to make changes, and the same way we have function 1, we have function 2, and then we are basically, as you can see, like we are creating a random number from uniform distribution from -1 to +1, and then we are going to use that with the actual, that is going to be part of the equation, and then the result of that is added to this, and we return the result at the end from this function. So as you can see, def f1 of x of y, and then the result of that, the object that we are returning is result, which is based on the user selection, whether they select sine or cosine. And then we have got the second equation, very similar, it's almost same, but again this is the area where you can make some changes to make sure that the generative art that is created from your, like based on your input, is not as same as somebody else. So which means you have to make you can make a lot of improvement in these two functions. Like if you want to take an enhancement from this application, the generative art section, the functions are something that you need to make change. One more thing that you might not have noticed is, unlike our previous applications where we simply use st.selectBox, here we are using st.sidebar the component name. And the reason why we do that is how exactly you add a component to the Streamlit sidebar. So if you want to add a component to the Streamlit sidebar, in this particular case you can see radio button we have got, then you have to use st.sidebar.radio. So what is a radio button? A radio button is a very simple application UI component that you would use when you have a selected number of inputs, where you don't want the user to, you know, take a drop down and select, but you want to lay it out for them, so they can just go and then select whatever input they want, which means they don't have to click a drop down to see all the options. They can actually see all the options. It is all laid out very clearly, and based on the options that they see, they can select whichever option they want. And we have used a radio button, and we have a label for the radio button, and the output of the radio button goes to the object called projections. So instead of simply using, like I said, instead of simply using st.radio, we are using st.sidebar.radio, which is primarily for us to add a particular component to the Streamlit sidebar. So if you simply use st.sidebar, you would see it in the main section, but because we are using st.sidebar.radio, this is going into the Streamlit sidebar. So this is one way that you can add new components to Streamlit sidebar. So the more you do st.sidebar so on, so you would get a sidebar component. If you remove that, you would get the same component in the main screen. And the options here for this particular radio, like first you have the label that we are saying, simply select the art projection here, and then the second thing is the options that we have here are hard coded. So this might change, like in the future section I would also show you where we are going to use a list to dynamically generate the options for a drop down. But here for this particular case, we know these are the options, so we are manually hard coding these options, rectilinear, polar, whatever. The next thing we have is the markdown. I've simply added a markdown here, which means like if you want to define a section, you can also add a markdown here in your sidebar. So I'm just going to call it color selection, so that you know, like this future section is going to be color selection, selecting colors. Now this section that you see, it has two drop downs that are going to define the front color of the art and then the back color of the art. So one is the front color, which is like the pencil, and the back color, which is the background color. So let's make it a little bit more, you know, intuitive when somebody reads that option. So instead of calling it BG color, let's call it background color, and front or art color is something that we'll call the front color. So as you can see, this is a selection box, which means it's a drop down, and you can see that the drop down takes values from an object called valid_colors. And if you notice at the top, we would have imported valid_colors from Samila. So now this is an object that is available within Samila library that gives us all the valid colors that you can use with front and backend color, front and background color. So this is an object. So if you print this object, the list, this is actually a list, Python list. If you print this, you would ideally see, you know, a lot of colors being displayed. So instead of hard coding the value or letting the user guess the color, so for example, you might take user input as a text input. Somebody might type green, but somebody might make a typo in that, so now the color would not render properly. So to avoid all those issues, what we are doing is we are actually giving a drop down, dynamically taking the values from valid colors, so that anybody can simply use the drop down and select it. But do you want to give a default color? Do you have a preference when the art is first time generated? Yes, of course. That is what the index value is. So you're going to give a default color when it is loaded that takes as an index value from the valid color. So you can see the front color, which is index 30, and the background color, which is index 15. So like these are the two colors that we have got, front and background color. Once again, these are like areas where you can play with. And finally, now we are moving to the main section. Until now we were focusing on the sidebar, everything that we have in the sidebar, and now we are going to move into the main section that is going to actually show the chart, actually show the art. And to quickly summarize, in the the side section, we've got all these useful components for equation and projection and colors, and in the main section is where we are going to actually have the actual art. And this is again another place where you can make a lot of changes if you want to improve this application. So you can add new components to the sidebar, you can add enhancements to the main section. Right now, if you see, the main section is pretty plain, but this is another area where you can make enhancement so that the main section looks better. So the main section, we don't want the user to guess whether something is happening, like so we want to actually give a progress bar or a spinner so that people know that something is getting generated, and that's what I'm calling it, greatness is coming. So first, progress bar or spinner, so that's why we are enclosing this within the with clause. So everything that is happening here would be within the with clause. And the next thing is we are going to use the example straight out of Samila's documentation. And as you can see, what they have got is they've got generative image that takes two functions and then generate function. This is another area where you can make enhancements. As you can see the documentation, you can select a range there, you can start from a value, go till a value, and step by a value. So you can understand more about it in the Samila documentation. Right now I'm not doing anything there, but again, these are like places where you can get user input and make some changes. First, create an object G with generative image from the two functions that we created already, and then G.generate to generate the data, and then finally plot the data using Streamlit plot, and also like it takes value from G.plot, and it has three components: front color, back color, something that we have already seen, and the projection that we have. Now you might wonder why do we have so if you see this function, one thing that you might have noticed is that we are taking a value, sine or cosine, and we have an if clause within that, and then we are changing the output based on that. So if it is sine, then we are showing sine function. If it is cosine, we are showing cosine function. But if you see the projection, we are seeing a value called projection dot polar. So just notice this, projection dot polar, and it's not a text field, it's not a string field, it is an object. It's an object that comes from Samila. So what we want is, we want a way to give a value there, projection dot polar. So ideally, what if we had used the previous logic, what we might have done, we might have had a 5 or 6 level of if else classes, if elif, to say, okay, if it is rectilinear, say projection dot rectilinear; if it is polar, say projection dot polar; if it is hammer, say projection dot hammer. So we could have done that, but we didn't want to do that. That is not a very readable code. So what you see here is, we see an eval function, which also stands for evaluation. What does is, it takes a string and then it evaluates it. So it basically expands that string or runs that string and then takes the component or value that is inside the string. So what we are doing in this case is, one is a dynamic value, one is a static value. So projection dot is a static value, and projections coming from the radio button is a dynamic value. So we're just concatenating this and using eval function to evaluate that option and add that option, the result of this operation, into the projection argument. So we need an argument, we need a parameter for which we need to pass on a value like projection dot polar, but instead of using an if else clause with the radio button, we are actually doing an evaluation, taking this as a string value, concatenating it, and then evaluating this entire thing, so that the output of this, so in this case, if the radio button says polar, the output of this would be projection dot polar, and then that get, like if the output is hammer, that gets added projection dot hammer is inside code, and you use eval to evaluate it, and then that final output is added to the projection value, which is passed as a parameter. And then finally we want a like a small message. You can use st.write. I've used caption just for a change, so you can give the seed value. Like I said, we have a lot of random math calculations, so for somebody to regenerate this, you need the seed value to reproduce this. So we are giving the seed value also to the user in case if they want to reproduce this. Imagine like you have uploaded an NFT and you want to regenerate it, share it with somebody. So for all these reasons, it's good to show the seed value to the user. There are a lot of different places where you can make enhancements to this. Like right now, if you see like this is quite plain. Like even if you see the seed value, it's quite plain. But in the future, you can make an enhancement where you can collect the seed value from user to regenerate it. Right now that component is not available in this application, right? So we share the seed value after we do that. The next thing is, right now I've not added any download image button, I've not added a tweet button or anything like that. So you can see if somebody wants to download the generated art, they have to right click it and save it as an image. But that is another important improvement that you can do. And there are ways, you can even upload it directly to an NFT storage. Like I don't know whether it supports OpenSea, but NFT storage is somewhere like you can collect the user API key and then directly upload the image to NFT storage. If you are into Web3 or if you want to develop your application into actual NFT creator, actual NFT art creator. So that is another improvement that you can do. So where you can add functions to directly upload the generated image to the NFT storage with the API key. Like you can collect the API key in the sidebar and then add it. So these are like enhancements that you can do, like lot of potential. So it's not just whatever you are learning in this application, like whatever you are seeing me code, it's not like you have to do that. You have a lot of options to grow, whether it is the option that you can whether it is the option that where you can make it in the sidebar, or whether it is the option that you can update it here in the main section. So the options are enormous. Add download button, add tweet button, like whatever you want to do, add it. And also, like, you have different options: upload it to NFT, save the image, like you have function g.save image, and you can also save the JSON file, the data file. So like you have like enormous option for you to do. Let's run this application and then let's see what happens here. And as you can see, like it shows connecting, and we are showing we have the title Generative Art Creator with the emoticon in Python, and then we have the hyperlink where somebody can go learn, and we also have the progress bar or the spinner that makes the user understand that something is coming, and we are calling it greatness is coming. And as you can see that it has already managed to create its first art. As you can see, the first art is there. You can just right click it. The user can, not just user can right click it, save it, copy the image, tweet it, whatever they want to do. Now you can start making, playing with the parameters. So there is like, now instead of the second function to have a sine math function, you are changing it to a cosine function. So you can see how the art has changed when you see it. I mean, I don't understand generative art that much, but for people who understand, it might make a lot of sense how this change is happening. But yeah, from a mathematical perspective, you can see that when sine function is changed into cosine function, what is happening. So again, like you can change the color, like here from the sign that we had, we are changing it to hot pink. So this is hot pink and polar. And also one thing that you might have noticed is, that I make two changes, and it's still, the app finally make one change, because the last state that you updated in the Streamlit options, like I can make 3 back-to-back changes, but every time the last change is made, this app refreshes for that change. This is another good thing. It's not like, user has to wait for the first change to take in place, then the second change to take in place, then the third. So right now I made pink and polar, so you can see the color would also change pink and then it would change polar. Like when you make back-to-back changes, that's a good thing. So you would polar is circular, like a radial. So like I don't know if it's supposed to be called pink, but yeah, so you have pink and polar, so that you have both the changes happening at the same time. Let's make a change. Let's make another color change. I think yellow would look good. So as you can see, it takes a little bit of time because it has a lot of math functions involved, and again, it depends upon the kind of machine that you have got. Right now we have got the polar, sine plus cosine, and the yellow color. So right now you can again like right click it, save it, and do whatever you want. And so as you can see that we have successfully managed to create the application. You can play with different colors, you can play with different options here. So the colors that you have, like these are like valid colors, and you have different sections to show the generated image. This is like the core section that you just saw, and yeah, so like if you do not want the title to be this big, like you can see that it is dropping. If you want it to be like one level below, you can make a subtitle. So when you run this thing, it shows like a small image, small font. Then you can actually change it to the markdown and add title. Like if you want like a 2 title, you can either do str title, or you can do markdown with hash. 1 hash is h1, 2 hash is h2, 3 hash is h3. So you can do all the changes that you want in the main section, and so you can also make changes in the sidebar, and we can play with different colors. We can play with whatever we want, and yeah, so that is it. So as you can see, like we have managed to successfully create a generative art creator or NFT art generator in Python using Samila. And unlike our previous videos, I'm not going to show you how to deploy this. I think we have already seen a lot of tutorials how to see in the last 6 days, how to deploy something on Streamlit cloud, how to deploy something on Hugging Face Spaces. I would love to see if you deploy it, if you manage to deploy this. But otherwise, even if you generate an image, even if you use this on your local machine, I would love to see what you have created, because like right now generative art is really good, and we are not using any deep learning techniques here. Like, we are not using style GAN or anything like that. We are simply using existing Python library that doesn't have any dependencies, that is built on top of certain mathematical functions, and then we're trying to create art with that looks there is an R library based on which this is inspired. So make sure that you check out that Samila library, and then give a star if you like this. Also, if you like my work, please let me know in the comment section, and let me know if you build anything new. I hope you stay safe, take care, happy coding.